Okay, there you go, guys. Then we have 1, 4, and 5. Yes. Yes, so you could have written what is it, 0.67. That's fine. Yeah. Okay, guys. First, block number 1 and 4. Those were already given in standard form. Remember, you always have to check that. So what I did was I just wrote on the side what all of those three values are. You don't have to do that, but it makes it just a bit easier when you actually get to studying it. Yes. Okay, so here, this one's slightly different from the ones that we did yesterday. I actually don't think we had a number other than 1 in the ones that we did yesterday. All right, but remember your A value is the number in front of x squared. So in this case, it was 3. B, the number in front of x is 1, and then C was negative 2. Please, if you forgot that minus, just circle it or highlight it. But when you're marking homework, right? I don't want you to just tick or make a cross next to the answer. If you got it wrong, please look for your actual mistake and maybe highlight the mistake or circle it or something like that. Okay, so that when you are studying for the exam, you can actually look back and remember what you did wrong. Okay, instead of just being like, oh, I got this question wrong, I don't know why. Right, so please, marking homework is actually a big part of maths. Okay, you need to try and do it. Yes. All right, number 5 is going to start with actually doing some multiplication stuff. All right, so I think we can all see that this is not standard, right? So I think some of you might have moved this over first and that plus 3 before actually multiplying out. That's fine. I'll just write that for you quickly. If you wanted to do that step in between, so if you wanted to say 3x squared minus 3 times x minus 1. And then this is positive 4 for this term, so when you move it, it will become negative 4. And then this plus 3, if you wanted to move that, would become negative 3. You could have done that first. Okay, so you could have done the movement first, and then multiplied half. It's fine, you get the same answer. Okay, but what I did was I multiplied the brackets after. So remember, if you have a number in front of the bracket, you must multiply by every term in the bracket. So we have negative 3 here. So negative 3 times x is negative 3x. And negative 3 times negative 1 is positive 3. Okay? Equals, there I multiplied my 4 into the bracket. 4 times 2x is 8x. 4 times 1 is 4. And then we have the plus 3. Okay, then I moved everything across. I didn't actually show that step, so I'll just add it here. So if you wanted to actually, because see, I'm going to the standard form straight away. But you could have put in an extra step where you are actually moving this stuff. So if you move positive 8x, it becomes minus 8x. If you move plus 4, it becomes minus 4. If you move plus 3, it becomes minus 3. Okay, it's fine if you put in that step and then simplify all of it. Right? Nothing wrong with that. So let's see here, we're looking at our x terms. We have 3x squared, then we have negative 3x minus 8x, negative 11x. We have 3 minus 3, which is 0, right? But then we have another minus 4. So that's exactly minus 4 coming from, equal to 0. Any questions on that? Yeah, then I just wrote down my A, B, and C values. Guys, please remember you have to show this step. All right, if you want to leave out the step, it would be the one we're actually writing the formula down. You don't get a mark for writing the quadratic formula, but you do get a mark for this, for showing what you are substituting in for A, B, and C. Okay, you're going to lose that mark. So in the check final, if that line is going to no, the marks have just come out wrong. Okay. Sorry. Okay, so then you get 2 answers. Did anyone use these 2 answers? 4 and negative a third. For this one, you can write negative 0.33 also if you want. Okay, that's fine. All right, number 9. That one, we just speak about the case where that one is almost in standard form. We just need to move that 10x. right? So positive 10x, when you move it, becomes negative 10x. Also, please just take note that I put it in those two terms because I like having it in the correct order. Okay, it's not the end of the world. It doesn't have to be in the correct order, but I like having it x squared and then x and then number. So my a value here, what number is in front of x squared? 1. What number is in front of x? Negative 10. Good. So that's my b value. And what number is just the constant term? Negative 24. Okay, so then, you're right. They just look at your so then you sub that into the formula and you get your two answers, 12 and then the other one is negative 2. Right? Is anyone doing that? Yes, cool, thank you. Okay, let's look at the next one. Last one actually, number 16. Okay, so sorry, which out here. For number 16, we hopefully see that we have a binomial multiplied by a binomial. Remember for that, use FOIL, right? So that is what I did. I FOILed them out and then I got to those 4 terms and then I also moved this 9 over to this side. So remember you have to have everything on the one side and 0 on the other side. So let's just go over that FOIL quickly. For FOIL we do first. So 2x times 2x is 4x squared. Then we do outers. 2x times negative 5 is negative 10x. Inners, 3 times 2x is plus 6x. And then last, 3 times negative 5 is negative 6. Like I said yesterday, if you make a mistake in that actual multiplying out, right, you would lose that mark, but then you will mark with the mistake going forward. Okay. So then I just add or just put together like terms. So 4x squared, that's the only x squared term that we have. So I just rewrote that. We have negative 10x plus 6x, which is negative 4x, right? And then we have negative 15 minus 9, which is negative 24. And guys, when it's getting to negative numbers, especially if you're rushing, it's easy to make an additional subtraction mistake. So just use the calculator for that. It's fine. Even for these x's, you can just type in negative 10 plus 6, right? Just because there's an x doesn't mean you can't use the calculator just to check that. I don't want you guys to be flustered, you're rushing, and then you lose a mark or something like that. Okay. So now here we see that a is 4, b is negative 4, c is negative 24. And then sub it into the formula and then you get your 2 answers. Now guys, something else that you could have done, all right, from this step, I'm going to write it at the bottom here. I'll just rewrite this step again. Still with us, right? Okay. Yeah, so guys, you got to do all 3 of those first. Now, you don't have to do this, okay? Because like you saw, when you start these times, instead of that formula, we are getting the right answer. Yes. Yeah? Okay. So what you can do, and I think they refer to this as dividing through by 4. Which might seem a bit strange because you're probably like, why can't I just do that? Okay, so I'm going to show you now why. In an equation, you can divide through by a number. Okay, we remember how to take out a common factor, right? We see that 4 divides into all 3 of these, sorry. So we can write the 4 there. Then we're going to take each term and divide it by 4. All right, so 4x squared divided by 4 is x squared. Minus, because the next term is negative, 4x divided by 4 is x minus 24 divided by 4 is 6. Alright? This is what you would have had to do last year. Okay. Last year, if you got something like this, you would have had to use factorization. Because you didn't know the formula, right? And in order to factorize this, you first have to take off 4 And then factorize this trinomial. But now, guys, if I want to just get rid of this 4, because I mean, the 4 isn't helping me at all there in front. Yeah, what am I doing to the 4? The 4 is being multiplied by the bracket. No? Yeah, and what is the inverse operation of multiplying by 4? Dividing by 4. So when I move this 4, I'm going to take whatever is here and I'm going to divide it by 4. And what is 0 divided by 4? 0 divided by anything is just 0. Okay, so if I do that, if I take away that 4, I don't need those brackets anymore. I'm actually going to write this. You probably wouldn't have written that before. Okay, you can put that in there. Remind you, why did I put into that 4? You're actually dividing the 0 on the other side by 4. And then you end up with this. Because 0 divided by anything is 0. Now in grade 10, they probably would have jumped from there straight to there. And you might not have understood. Or even in grade 9, you could have done that. Maybe you didn't understand where that 4 is going. All right, why you can just do that. It's because of that 0 on the other side. I'm just going to go through this again. You see that we actually have a common factor here, 4. 4 goes into all 3 of those terms. So you can do that factorization. Then you divide the 0 by 4. It is fine if you go straight from that line to that, right? So you don't have to show these steps. But this is actually why you are able to do that, or allowed to do that. And now you could either factorize this trinomial, like we did on was it Wednesday. Remember, if you factorize something and you have 2 brackets, there we go. Then you make each bracket equal to 0 and then you solve. Or from here, you can also just use the quadratic formula. Okay, so from here now, if you did that, and they say you're dividing through by 4. Okay, but this is actually what you're doing. Actually taking it out as a common factor and then you dividing 0 by it. If you get to this, you can again also just use the quadratic form. Right, you'll get the same 2 answers. But it is so much quicker to just, if you have this, just use the formula straight away. Okay. But like I said, you can divide through by 4 as well. Right. Okay, now, are there any questions on any of those homework questions? What did I write to you guys? Hopefully, right when we're done walking, I want you guys to feel like, okay, if there was anything that you didn't understand while you're doing it, that you now feel okay with. Right? Okay, I want you to do some more of these where we have to do some algebraic stuff before we actually solve. Sorry, I'm just looking for, oh, my apologies, because we have to get into some. Okay, let's do a new heading. Let me just see what was yesterday. We just said the quadratic formula. Okay, so let's do a new heading and let's say quadratic formula continued, I suppose. Okay, so you can start writing that so long. Quadratic formula continued. We're not going to do anything today, we're just going to keep practicing. Okay, I just asked for most of you guys in this class last year. Put up your hand if you want. Okay, so solve for x. Now we're gonna go into some fractions, guys, but I don't want us to panic when we see fractions, okay? We need to memorize the method for dealing with them, okay? Because there is a specific method when you have an equation with fractions. So if we have this, so this one that I'm going to do now might not, it's not going to turn, it might not turn into a quadratic equation. I just want to provide what we do with an equation with fractions. Then we'll do one that becomes quadratic. Okay. So if we have this 1 plus 2 over x plus 4 equals 3 minus x plus 2 over x plus 4. I want you guys to write on the side there, okay? And whenever you see an equation with fractions, emphasis on the word equation, I want you to practice this method. Okay, so equation with fractions multiply each term by the LCD. You might have learned this last year, maybe you didn't, maybe you did and you forgot. Okay, but I want us going forward, whenever we see that we have an equation and there are any fractions, even if they're just one fraction, right? You need to multiply every single term. Okay, I'm going to say that again. When you have an equation with fractions, even if it's only one fraction, you have to multiply every single term, all right? Even the terms that aren't fractions. How many terms do I have here in this whole equation? 1, 2, 3, 4. So I'm going to have to multiply by the LCD 4 times. All right? Each term, every term, even if it's not a fraction, maybe I should just add that thing. Each term, even when not fractions. Yes. You can if you want to, but that is more when you have an expression rather than an equation, right? Because if in an expression, what you want to do is you want to write all of them with the same denominator before you can add and subtract them, which is why we would then write them as fractions. But when it's an equation, we actually want to get rid of the fraction. We want to get rid of the denominator. Okay, and this is a way of doing that. Let me just do this example. Okay. All right, guys, now when we look at this equation, obviously we see that we have 2 fractions. Now we need to look at the denominator of the fraction. Okay, so that we can find the LCD. Remember, the LCD is the lowest common denominator. Now in this case, we are lucky because the 2 fractions have the same denominator. Right, so that denominator is going to be the LCD. So you can write somewhere that the LCD here, oh goodness, not LD, LCD, sorry, that the LCD is x plus 4. So that means that we are going to multiply every term, all four of them, by x plus 4. Okay, so I'm just going to write it like within this thing here. I'm just going to put it times x plus 4. And it's good to put that x plus 4 in brackets because now it's two terms. Okay, so when we multiply something by two terms, we need to put brackets around. All right, so just do that, please, times x plus 4. For the next one, also times x plus 4. For the third term, which is just 3, times x plus 4. And for the fourth term, times x plus 4. All right, what is 1 times x plus 4? X plus 4, thank you. X plus 4. The next one has a plus in front of it, so we can put that plus there not. Now this one is a bit more complicated, guys, but do we notice, right, that if we have this fraction, so we can only have x plus 4 at the top and at the bottom. X plus 4, x plus 4. What happens if we have the exact same thing at the top of the fraction and at the bottom? Cancel out. Just draw a plain line so that you can still see what was written there, please. At the top, you actually have 2 x plus 4 in brackets. At the bottom, you have x plus 4. Okay? So you can cancel those x plus 4s out. So what is this? 2. Isn't that nice? We got rid of that fraction, right? That second term was a fraction. Now, by multiplying the whole fraction by the denominator, we are able to cancel that denominator out. Okay, that's why I use this method, because we get rid of the fractions right from the start. Okay, equals. Now 3 times x plus 4 is not as easy to do as this one, right? But you can just write 3 bracket x plus 4. We can sort that bracket out just now. I'm taking my third term and I'm multiplying it by x plus 4. Or if you want, you can multiply it into the bracket from the start there. Okay, that's also fine. If you see it's 3 times x and 3 times 4, you can do that straight away. Okay, that's fine. Minus, now this one is a bit more difficult. Because, and this is, I suppose, a very common thing in grade 10, that you can't just cancel out anything. Okay? You have to have one term at the top and one term at the bottom in order to actually cancel out. Now, in this case, we had an x plus 4 at the bottom of the fraction, but you could cancel it out because it was just the same as one. Okay, you can actually like put brackets around it and then kind of turn it into one term. We'll talk a lot for a lot of canceling later on. But in this case, guys, the way that it's written here now, does this actually look like one term? Not actually, hey. But what am I doing? I'm saying this whole numerator multiplied by x plus 4. So I actually have to put the numerator in brackets, the x plus 2. Because if I just leave it like that, if I leave it as x plus 2 bracket x plus 4, then I'm only doing the 2 multiplied by the x plus 4. Right? I don't know if that makes sense. When you are multiplying a fraction by x plus 4, you're multiplying the whole numerator actually by that fraction. So you actually have to put a bracket around. Okay. But do you see again? And also if we put brackets around the bottom here. Again, I have x plus 4 and x plus 4. Right? Can we see that at the top and the bottom? So I can cancel those out. Now what's left here at the top when I cancel those out? X plus 2, very important guys, x plus 2 in brackets. So what am I doing? I'm supposed to subtract this whole thing. So when I'm subtracting multiple terms, I have to put them in brackets. Maybe highlight that, guys. That's very important. That's also a common mistake. The actual brackets thing. We are going to practice lots of fractions, okay? Because I know it was quite a big thing in grade 10, and then we do need to be able to do these in grade 11. Yes. You can put a bracket, yes, but you can only actually do that if what you put brackets around is exactly what you have at the top as well. So I'll just do something on the board. Let me just see. So if I have something like this, right? X squared minus 4 over x plus 3. You guys see that I have 2 terms over 2 terms, right? So I'm not allowed to cancel out anything else. I can turn this into one term by putting brackets around it. And I can turn this into one term by putting brackets around it. But do I now have the same bracket over the same bracket? No. So even by doing that, even though I now technically have one term and one term to put brackets around it, I still can't cancel it. Okay, what do I have to do in this case? This is a two ways. There's a spot. Can I see that? Okay, so this would be x plus 2, x minus 2, over x plus 2. Now let's touch the bracket on the bottom. And I have the same bracket at the top. Now I can actually count that. Okay, and now my final answer will be x minus 2. So in some cases, putting brackets around 2 terms, like you did here, does actually allow us to cancel. Right? So it's not always going to allow us to do that. Like here. Put brackets around the two, put brackets around those. You do have one term or one term, but because it's not the same two brackets, it's not functional. That was the question. If you want, you can write this down and find something. I'll do that out. Okay, to this one. Yeah, now guys, to get back to the whole fractions and equation of fractions, I've now multiplied each term by x plus 4, which allowed me to cancel out the 2x plus 4 that I had as denominators. And now I have a linear fraction. A fraction without, linear equation. An equation without fractions. Okay, which is easier to solve. So now, what is x plus 4 plus 2? What's 4 plus 2? X plus 6. Okay, so I'm simplifying that side on its own. So that we have more or less things to work with later on. And now I must multiply these two brackets out. Okay, so 3 times x is 3x. And 3 times 4 is 12. And then negative 1, we now multiply in here. So remember, if there's no number written there, then there is actually a 1. So negative 1 times x is negative x. And negative 1 times positive 2 is negative 2. Okay, now you can do this in whichever way you want. I prefer normally if I have like terms on one side, I like simplifying that side before I start moving things across, but you can move stuff around from the beginning. So I'm just going to simplify this side here. 3x minus x is 2x, right? Find that. And then we have 12 minus 2, which is 10. And now to solve for x, we're going to just get all the x's on the one side and the numbers on the other side. Now again, it's up to you guys. Some people prefer to just always have x's on this side, alright, which is fine. Or if you see that if we move this x to that side, it's up to you really. Let's work on the left-hand side. So I have an x here at the moment. If I move this positive 2x, what is it going to become? Minus 2x. Right, this is an optional step. You don't have to write this down. I just like showing all steps so that people follow what I'm doing. So I'm just moving all the x's to that side, right? On this side, I already have a 10, but then this positive 6 must move is going to become minus 6. Okay, what is x minus 2x? Negative x, okay, good. And 10 minus 6 is 4. And what if I do with that -1 that's there in front? Take it to the other side, hey? What is the opposite of multiplying by -1? Dividing by -1. What is 4 divided by -1? -4. Okay, some people say you're just moving the minus to the other side. That's fine. You can think of it in that way. Okay, so x is -4. Now, now we're regretting choosing this question because now what's actually happening here? Do you guys remember from last year that when you are solving an equation with fractions, you always have to check if your answer actually works. Now, to check if your answer works, you will have to substitute it back into the original equation, right? And check what are you getting on the left, what number, and then is that equal to the number that you're getting on the right? And as we're looking at this fraction, and the same thing will happen here. I have 2 over x plus 4. Now the value that we got for x was -4. So if I have -4 plus 4, what is that? 0, hey? I'm just going to say that again. We're getting an answer of -4 for x. So let's substitute it into this fraction and see what happens. X plus 4 will then become -4 plus 4, which is 0. Can you ever divide by 0? Can you have a 0 as your denominator? Is that a thing? Let's look on the calculator. What happens? Oh, I can't find my calculator now. That doesn't work. Let's check my rules quickly. Type in 2 over 0. What happens? 2 over 0. 2 divided by 0. Same thing. It's math error, eh? You can't do that, right? How can you divide something by nothing? How does that work? Okay? 2 over 0, 8 over 0, it won't work. It doesn't exist. So this answer is actually invalid. Right? Even though it works in the sense that it makes the left-hand side equal to the right-hand side, yes. But it makes the left-hand side equal to something that can't exist, and the right-hand side equal to something that can't exist. Because it makes the denominator equal to 0. Let's write that on the side. So sorry about that. I didn't realize that this was going to happen now in this question. This answer is invalid because it makes the denominators equal to 0. Which is, and then I'll just say what it is on a calculator, a math error. But we actually say that it's undefined. You might remember that term from last year. Okay, now if that happens, you need to write underneath this. You actually need to draw a line through the equal symbol just to show that x actually can't be equal to -4. Now, if x can't be equal to -4, then what is x? Okay, the one answer that we got doesn't work. But is there an answer? Okay, so therefore, no solution, which is something that we covered in grade 9, where you did equations where you are getting, you guys remember, like 2 equals 3. You remember that? Right? If you're getting like 2 equals 3, then that means that there's no solution. There's no value for x actually that will make this equation work. Okay, so sorry, that turned into a more complicated question than I was looking for, I actually just wanted us to practice this multiply each term by the LCD. Okay, so don't get too hung up on this now, guys. We're going to keep practicing this method. When you have an equation with fractions, multiply each term by the LCD. Okay. I'm not looking at the book, it's just now I get another one of those. I'm just going to do one more with you, and then you are going to just do some on your own. So if we have number 2. 3x over 2 minus 1 over 4 is equal to 5 over 4x. I'm going to zoom in slightly so that it's a bit clearer. Okay, so what I want you to think when you are seeing this is that this clearly is an equation. There's an equal sign or something on the other side of it. And we have fractions, right? In this case, actually, all 3 terms are fractions. Okay, so it's a bit different from the previous one. So I'm just going to write again on the side, equation of fractions. So we're going to times by LCD. Okay, in the previous example, we had 2 fractions and they both have the same denominator. Right, so the LCD was easy to find in that case because it was just x plus 4. Now in this case, we see that we have 3 different denominators. Right, so whatever we make the LCD, we need to make sure that all 3 denominators can divide into it. Okay, so the LCD is something that all, I'm just going to say denoms for denominators, right, can divide into. And the L stands for lowest common denominator. So we need to try and find the smallest number, the smallest thing. But if you get something that's bigger than what I'm saying now, if it's right, you can't go on. Okay, so let's look at the 3 denominators that we have. Now, since we have numbers and a variable, let's look at them separately. Okay, so the numbers that we have are 2, 4, and 4. Now, what is the smallest number that 2 and 4 can both divide into? Can 4 divide into 2? I'm going to ask the question again. The smallest number that 2 and 4 can divide into. Isn't it 4? Right? Because you can say 4 divided by 2 is 2, but then you also need to be able to say 4 divided by 4 is 1. Okay. Now, you can divide 4 into 2, but then you're going to get a half, and that's not what we want. Okay. So I'm going to say that again. The smallest number that 2 and 4 can divide into will be 4. Okay. So our LCD definitely has to have a 4. And you can do that as you are identifying things that need to be in your LCD right now. Okay, so 4 has to be in the LCD. In fact, you might think that 8 is another option, right? Because 2 and 4 can both divide into 8. Do you agree? Well, that's not the lowest one, but it's fine if you use that one. Okay, you won't get to an incorrect answer. Your wording will be a bit different, but it's fine. Okay, I don't want you to get hung up on that. Just need to find a number that is as small as possible that all of these, the 2 and the 4 and then 4 again, can divide into. Okay, so 4 is fine, 8 is fine, even 16 is fine if you want to use that one. Alright? And then we have an x as well. Alright, in order for 4x to divide into our LCD, we have to have an x in our LCD as well. Alright, so whenever there's a variable in any one of your fractions, that variable has to be a part of your LCD. If we have an x squared somewhere, we will have to have x squared. Right? If we had a y, the y must also be in the LCD. Okay, so you look for that multiple, hopefully the smallest one, but it's okay. You look for the lowest common multiple actually of your numbers, and then all of the variables to their highest exponents must go into the LCD. Okay, but we look at that combination. And the LCD is 4x. So times 4x times 4x times 4x. It helps to actually write it down like this. Right, because then you can see very easily what's left with what is happening. Okay, now what is happening here in the first fraction? The denominator is a 2, right? What do I actually have at the top now? What's 3x times 4x? 12x squared, okay? And at the bottom I have a 2. If you want, guys, you can actually write that as a separate step. Right? You can actually write that down. Because now it's easy to see what I'm going to be left with if I divide that. Okay? So you see what I did? I just rewrote 3x times 4x as 12x squared. That's all I did. Okay, I haven't actually worked anything out. I haven't cancelled anything out. I've just done that multiplication there. I got 12x squared. Minus, what's 1 times 4x? 4x. What is the denominator that I have there? 4. So I'm putting in an extra step that I didn't put it in the previous example. Okay, I'm actually doing the multiplication and this bracket. Then I'm going to do the cancelling off. It might be a bit easier for you to do it in that way. And here on this side, this cancelling out is actually quite easy to see. You guys notice that because I have a 4x and a 4x. Right, so you can cancel that out straight away if you wanted to. You basically just do what is best for you. Okay, if you want to multiply them first and then cancel out, that's fine. If you want to cancel out straight away, that's also fine. All right, for this one, because the times and the denominator is exactly the same, it's very easy to just cancel out. So what's left then? If I cancel that out, 5. Now let's just quickly simplify these first two fractions. 12x squared divided by 2 is 12 divided by 2, 6x squared, right? And now here, minus 4x divided by 4. What's 4 divided by 4? 1, right? The 4's cancel each other out. So I'm just left with x there. And that is equal to 5. So we now notice that we have no fractions. Okay, that's what we want. That's why we multiply each term by the LCD, so that all of the denominators can cancel out. What kind of equation is this now? Quadratic, right? Because there's an x squared. Right? Do we notice that? Let's circle that too. This is now a quadratic equation. In the previous one, we got a linear one. Okay, this is a quadratic equation. And what do we use to solve a quadratic equation? What did we learn about yesterday? Quadratic formula. Yes, that's the easiest way of doing it. But before we can use the quadratic formula, we need to get it in standard form. So this 5 needs to move to the other side. Yes? Okay, so 6x squared minus x. It's positive 5 on this side. So when we move it, it's going to become minus 5 is equal to 0. What is my a value? 6. A, remember, is the number in front of x squared. A is 6. My b value is negative 1. The number in front of x is negative 1. And c, the constant term, is negative 5. Okay, now we're gonna write the formula. I'm just going to write it out again because we've been doing a lot of other stuff. I just want to remind you of what that formula is. And guys, you have to memorize this. Okay? We're not going to give you this formula in the test or exam this year. Next year you get formula 3, so in grade 11 you have to memorize these. So negative b plus or minus the square root of b squared and that is then over 2a. Now we're going to sub our values in. So now b is negative 1, so we have to say negative 1. Please remember that. Whatever your b value was, you need to put a minus in front. Okay, then we do plus or minus the square root of negative 1 squared minus 4 times 6 times negative 5. That is all over 2a, which is 2 times 6. And then we can type that into the calculator. So you're going to have to tell me what these answers are. Yes?
You can't cancel multiple terms with a fraction.
What do you
I
mean?
mean, just start over to 12x squared over 2. Just that one.
Yeah.
You can't cancel multiple.
You mean across multiple terms?
No, I'm asking you, possible, like, say it was 12x plus, I don't know, 3 over 3. You'd have to make that one.
Yes. Negative 5. Thank you. Does anyone else get these values? Oh, sorry, 5 over 6. My apologies. 5 over 6. There we go. Yes. Okay. Guys, like I said yesterday, if you make a mistake in like working with these fractions and this is wrong, you will lose some marks. It obviously depends on what you did wrong and how complicated the question is. But then whatever you get here, if you are subbing in your A, B, and C values, then you will get this substitution mark and CA marks for the final one. Okay, so you can get at least 2. Sometimes they give 3 marks, sometimes they give a sub mark and a mark for each one. Right? You can get 2, maybe 3, even if you make a mistake. Right. Your homework. So you all have to put now, yes? Yes, okay, your homework is from the same exercise. I'm not going to write the questions down now. You'll have to look in your books. And guys, it is quite a good idea maybe to start the class group chat so that you can, just maybe one person can take a picture of the answers on the board and send it on the group chat or whatever. But I will also put it on Classroom, which is, Just on page 30, I would like you to do numbers. Number 10 is just another one like the one we did yesterday where you must multiply out. Okay, so number 10 doesn't have any fractions. Then I want you to do 18. Okay, those 4. 9, 10, 18, 21, and 23. You also 7 minutes left. I would like you to start working on these now, please. Put your notebooks out. Stop recording here.